You hear the bell, that means class started. That just happened to be a coincidence. Today we're moving on into the new section of our notes. We're starting with functions. So yesterday we learned about domain and range and ordered pairs. Today we're going to learn about functions. A function is just a set of ordered pairs in which the first coordinate denotes the input, or what's going into the function. The second coordinate denotes the output. Now, back in the older days, I've seen it like a machine, where they have in, and then something happens, and out. So if you put the number 3 into the machine, add 2, 5 comes out, right? So that's like middle school stuff. But it's the same concept. It doesn't change at all. For each input, there's one and only one output. So if I put 3 in, I have to get the number 5 out of this machine. I can't put 3 into some machine or the function machine. I can't put 3 in and get 5 and 9 out. It has to come out with only one output. So if I put an X in, or the domain in, there can only be one Y that comes out. If we look at ordered pairs, we can tell whether something's a function or not simply based on what came out. So now let's explain why each is or is not a function based on the ordered pairs. If I look at this one, I have 0, 0, 1, 1, 1, negative 1, 4, 2, 4, negative 2, 9, 3, and 9, negative 3. I can look at it as the ordered pairs, or I can list my domain out. So let's list the domain out first. That's all my X values. Domain, squiggly bracket, 0, 1, 1 again, so I don't have to list it, 4, 4 again, 9, and 9. That looks like a 3, but it's supposed to be a squiggly bracket. Let's fix that. That's better. Now let's check my range out. Range, 0, 1, negative 1, 2, negative 2, 3, and negative 3. 0, 1, negative 1, 2, negative 2, 3, and negative 3. Again, this is a squiggly bracket. When I look at my domain, there's only 4 terms in it, 4 numbers. When I look at my range, there's more than 4 numbers. That's a surefire way to know that it is not a function. If there are more numbers in the range than in the domain, this is not a function. Now, that's the easiest way to tell. But we don't really have to do all that work. I can simply look at my ordered pairs, and if any of my x's repeat and the y's are different, so I have one repeating and the y's are different, I automatically know it's not a function. There's yet another way to tell, and it would be to graph these points. So we would just put these points into a graphing calculator or graph them on a sheet of paper. And when I put these points in, if I draw a vertical line and it goes through 2 points, then it would not be a function. So a lot of different ways to come up with the same result. Okay, I want you to try B, and then we will do it together. So you should be pausing the video. Okay, let's look at B. If I'm just looking at the ordered pairs, I have 0, 0, 1, negative 1, or sorry, 1, 1, negative 1, 1, 4, 2, negative 4, 2, 9, 3, and negative 9, 3. First, did any of my x's repeat? An answer would be no. They're all different numbers. 0, 1, negative 1, 4, negative 4, 9, negative 9. None of them are the same. Did my y's repeat? Yes, but that does not matter. Your y's are allowed to repeat, and it will still be a function. The x's can't repeat. That's all that matters. So this answer would be yes. If I listed out my domain and range, my domain would be larger than my range. That's allowed to happen, just not the other way around. Your range can't be larger than the domain. Let's try another one. C. For this one, I have 0, 0, 1, 1, negative 1, 1, 4, 2, negative 4, negative 2, 9, 3, and negative 9, negative 3. What do we think? Would this be a function? Check your x's. 0, 1, negative 1. No repeats so far. 4, negative 4, 9, negative 9. Nothing repeats for our x's, so this would be a function. That's it for this one. Looking at a graph, we can find the function values as well. So for every x on this graph in red, there is a y. So for every input, which is your x's, there's a y that comes out. So if I go over to 4 for the input, that's at this point here. Where's my y? Well, I just go up to where the graph is. The graph is here when x is 4. What value is this? 3. So my answer, the output when the input is 4, is 3. Find the inputs whose output is 0. So when my y is 0, what went in to make that y 0? So if I draw a line through 0, y equals 0, let's look at all the places my red graph crosses my red line. It crosses here, here, and here. So that's at negative 3, 0, and 2. Those are my answers. X equals negative 3, 0, and 2. Find the y value that corresponds to x equals negative 2. This is where it can get a little trickier. Let me get rid of this. If I go back to negative 2 for the input, you'll notice that my red graphing line has this little hole here. And that means as the red line gets closer to it, like it's the same spot on both sides, but there's a gap there. Up above, you'll see that there's a solid dot. An open circle means that it does not include this point. So my output when x is negative 2 is where my dot was up above. The open circle says it's not here. It's not in this spot. So it's up here. That's called a hole in the graph. So my y value for this red dot is 3. That's my output. Y equals 3. So anytime you see a hole in the graph, you can't count that one. Now it tells you to state the domain and the range of the function. This is a little different than what we had done before because we had actual ordered pairs. So now we have to figure out where this function exists at. So our domain is still all the x's. So where is there red on this graph as far as the x's are concerned? It starts at -4. It goes all the way. It stops here. There's a hole, but the hole gets filled in. So it continues the whole way across to this point. So my domain would be from -4 less than or equal to x. So all my x values have to be between -4 and 5 because that's the endpoint of my graph. Another way to write this, whenever you have, well, a couple things. It has to be a less than or equal to sign because our dots on the end are solid dots. They're not open dots. So that's why these have to be less than or equal to signs. If this was an open dot, like this on the end, that would mean it's just a less than sign. So that's how we determine that, whether it's a less than or equal to or just a less than. The other thing here is that there's another notation for this, and it would be bracket -4, comma, 5, bracket. You use brackets when it's a solid dot. If it was an open dot, you would use parentheses. So if this was open and this was open, it would be parenthesis -4, 5. Now that looks like an ordered pair, but you have to put the domain before it. Domain is from -4 to 5. Open. What if one dot was closed and the other was open? So if I had a closed dot here and an open dot there, then I would do domain from -4 with a bracket in front because the dot is closed to 5 with a parenthesis. So that's all the different ways that we could notate the domain. Now let's find the range. The range is all of the possible y values that are shown on our graph. So I'm going to go to the lowest y value, which is there, and I'm going to go to the highest y value, which is there. So our range has to fall between these two areas. Would have helped if I'd have drawn a straight line, or at least straighter. I think there's something wrong with my board, actually. Anyhow, we can see that that top point is 3 and our bottom point is -2. So our range goes from -2 less than or equal to y less than or equal to 3. That's our domain and range. I could do my range the same way that I did the other notation for it. Bracket, because it's less than or equal to, and a solid dot. -2, comma, 3, bracket. And that's it. Function notation. This notation trips people up, but it's really not that bad. F of A denotes the output by the function f produced by the input of A. So if you look at the first one, it says f of x equals x to the third minus x plus 4. That just means if I put an x in here, then an x replaces everything in this function. Everywhere there's an x, there's an x. What if I change that x here to a 3? Now it says the function of 3. It means that everywhere I have an x in the rest of the function, I change that to a 3. 3 to the third minus 3 plus 4. This is a function of 3. 3 to the third is 27. 27 minus 3 is 24. And 24 plus 4 is 28. That's all there is to function notation. Don't make it harder than it is. It's a function of x or a function of whatever number we need to plug in for x. That's within our domain. Give you a chance to practice some of this in your homework tonight. Okay, that's about it for the lesson. If you need to meet on Google Meet, make sure you show up. I will be there tomorrow, be there Monday. So if you need the help, make sure you're coming to the Google Meets and getting it. Thank you. Have a good day.